What's up, guys? I don't know if we'll get any viewers on this one. It's quite late. But yeah, I'm streaming. I'm gonna start doing this a lot more regularly because it's fucking fun. I love it. And yeah, I've gotten a lot of motivation recently for for working on this project and all that stuff. So this one's gonna be kind of a cozy stream, more or less. Slower pace, maybe. Gonna have a beer, some nice Czech beer here. Yeah, cozy stream. So the mic is louder than like usual for some reason. I don't know if the audio is good. I tested it and I was like, oh, okay, it's alright. But it's like louder. I don't know if it's because I'm using this one versus this one. For some reason it has two. I don't really know which is which. I'm just like, okay, whatever. Anyway, let's see who we got. Open up the chat. Oh, this is really good. What is this one? Staro Pilsen. Pilsen, okay. Yeah, this was $3. Pretty expensive. Hard to get. There's not that many like Czech Pilsners, at least that are common, you know. Well, you got you got your Pilsner Urquell, of course. Bottles are tiny though. Like, look at this, teeny little bottle. All right. We won't reach Bomber's Peak, but I already had a beer, so maybe it won't be that good. But yep. Let's see. Okay. I got You don't have beer with your breakfast? When I was in Czech, like on vacation and stuff, I was still working kind of like part-time. It was hard because, I'd be like, okay, this is going to be a work day. I'm going to work today. And, is the audio good, by the way? See, it's getting in the yellow a little bit. I don't know. Anyway, I'd be like, this is a work day, I'd buy like these weird knockoff energy drinks from the like village market or whatever. This is like not like middle of nowhere, but like kind of small village, They have like these weird fucking brands like Wolf Cola. Wolf Cola. It's like an energy drink that's a cola. Like Jolt Cola or whatever. They have like all these weird kind of brands, you know. I would just buy like all the different types. Anyway, it was hard because every time, you know, you have a meal, you know, you're offered beer. It's like, how can I say no, you know? It's like, you know, it's lunch. I'll have a beer, but it's like a big boy beer. It's never like one of these fucking tiny little things. You know, you have like 3 or 4 a day, so it's kind of hard to be productive. But anyway, that's check. So I really want to put this online, this documentation, because I feel like if someone like goes to my repo, they're like, oh, what the fuck? If someone goes to my repo, they're like, oh, okay, this is kind of neat, and they're just like, oh, where the fuck do I start? The fuck is this? Oh, they're trying to do some like Zapier shit or something. Okay. Okay. They'd be like, oh, where the fuck to start? Just a pro tip for all you newbies or people that don't know. If you are confused, like if you see a project like mine or any huge project, mine project's not huge, but if you see any big project or like you want to like understand what the fuck it's doing, sometimes you'll just see a project and it'll be like abstract something, blah blah blah, and you're just like, I don't know what the fuck this means. Go to the source code or wherever the tests are, go to the tests and look at the test, like, and you'll be able to see, like, by the end-to-end test, you'll see, oh, okay, I know what the fuck's going on. And you'll be like, okay, that makes sense. So, that's my strategy anyway. Like, if I don't know what the fuck a project is, I'll look into tests. Because the test kind of is, it's like a, you know, it tells you a lot about the project. Anyway. Did I lose my desktop? Fuck it. Let's create a new one. I probably didn't lose it, to be honest. That's good. Let's. Yeah, it's right here. Okay, so desktop. Change dir. And then, okay. Why is that undefined, motherfucker? Okay. So I decided when my startup makes millions of dollars, I'm gonna get one of these. Just fuck it. Like, why not, right? You fucking made it, you know? Who cares? It's a fucking iPhone, whatever. What the fuck? Look at this shit. Holy fuck. Okay. Anyway, a good start. So that's the goal. Okay, where we at? Client node is clearly not anywhere. So, alright. I'm gonna look at the commit that we made last time. You know, that's always a good way to start, because, you know, you'll look at it and you'll be like, oh, okay, I know what the fuck happened last time. Also, so I might get my live stream privileges revoked by YouTube if I go to like YouTube or whatever. I'm not gonna do it, but like I have to appeal a video because there's some music playing in the background, but like they were just coming from my earbuds, like you could barely hear it, and somehow YouTube's algorithm picked up on it or some shit. So now I have to. I did a fair use thing, and then like they said no, even though every other song said okay, it's fine. So I like appealed it, and they basically said like if you fail the appeal, then you fucking get a copyright strike. And I'm pretty sure if you get one copyright strike, you can't live stream anymore or some shit like that. So let's hope that doesn't happen. Anyway, so dumb. Copyright needs to be reformed like hardcore. Yeah, okay. Like hardcore. Okay, what the fuck we did? Fix the seg fault. Oh, we did the ID thing. That's right. That's right. That's right. So get unique store. So yeah, I'm like kind of thinking starting a company. Yeah, this is a chill episode. We're gonna go slow. We're gonna go slow. Uh-oh. Stinky. Uh-oh. 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 Stinky. Poop.
Poopy. Funny poopy.
That's so I really want to like rant. But I don't know what to rant about. Someone give me a subject. Well, first let me like get into some shit. And then I'll rant if someone gives me a good subject or something. C++17. Yes, it is. Well, I'm using Clang actually because of libclang being like good for the autocomplete and shit and Emacs, even though C++ and Emacs seems to like suck, or I'm just doing everything wrong. There's something very little isn't supported. Most features are like good, but the problem is like if we look this JSON. This is an old desktop config. So if we go to like file system, Um, like where the fuck? So, and wherever I include standard file system, I had to do the experimental header, which kind of sucks because, it's like experimental, even though it works. It should be fully supported, but some headers are just not considered out of experimental. I'm not sure why, so. Anyway, so we want to test the storage for sure. We're not really writing unit tests here. We're writing like an end-to-end test, which is more or less like, it's kind of a bad idea. I mean, for like starting your tests, you want to do unit tests first, generally, but I kind of wanted to scope out the API, shit like that. So maybe, enjoy your scroll. I'm gonna turn on my heater. Turn off my heater. It's gonna be too hot in here. And yes, my heater is in my bathroom for some god awful reason. Anyway, so where we at? Where we at? Where are we at? Where are we at? I'm pretty sure it compiles and links. I should be like compiling it in parallel, but I don't know. So it fails here because of, this is like config issues. It'd be better if like you ran the test in the build folder and it loaded the config elsewhere. That'd be better. I wonder if like if I do this, if I do like ... would that work? Relative paths, does that work? I have done that and it didn't like do much improvement, but at the time my code base was like really fucking I'm kind of curious though, so let's do this. Wait. Let me make sure I got this thing right down here. Does it? Oh, it seemed to be a bit faster, isn't it? The good old ARM star. Okay. Okay. So let's do test. We're gonna do time make. This is from scratch. So thing is, I think a lot of the files, generally speaking, have like interdependent parts. So I don't know if like that comes into play. So okay, so we got 24 seconds. I'm gonna try with 4 threads because I have like 8 total. I'm just gonna Shit. Let's put it here. Right. One thread. This stream's going off to a good start. Okay. Time make J4. Hello! This is a comfy stream. Welcome to the comfy stream. Okay, that took much fucking less time. Wait a sec. So, it took half the time real, but more time user. I don't even know what the second one is, to be honest. So, I like your theme a lot. Oh, thank you. I didn't make it, but thank you. I like the aesthetic. User insists or CPU time. Real is real wall clock time. So how come? Okay, well, let's try with 8 threads. I'm curious. For the sake of example. So if you have 4 threads, the time gets multiplied by the core count. Well, ideally, right? I mean, but not necessarily. No, I gotta know, because I gotta see, because, you know, sometimes I just wait there, it's compiling, and I stream on Twitch, so if my YouTube username is King Herring, so if you go to twitch.tv/King Herring, it's also there. Let's try 6, because I mean I have 8 threads, but like everything else is running, so like I have a feeling that it won't run very well. Core count plus 2, yeah, so that's, yeah. Okay, so yeah, that's I have 4 cores plus 2, that's 6, so 6 is good. Okay, well, okay, yeah. Cool, so that reduces our compile time in half. Thank you, Mr. Kiyumasu. That's how you pronounce your last name, right? Pretty sure. So what does my program do? That's a good question. God, I'm wasting a lot of time. So a content delivery network is a way of distributing storage across the globe to many individuals in different places while still contacting the same server. That's the most simple way I can describe it. So I don't actually have any of the geolocation shit down, but what I do have down is storage. Well, not really. Good. So basically I started with a single node and I got that working, and then I'm like, I need to re-architect this, so I re-architected it, and then I made the architecture into code, and now I have to make the new architecture work, and so that's where we're at. Okay, so where are we at in terms of the oh, okay, so what I want to do, relative. What? Returns path relative to root path. P dot relative path. I want to do like dot dot slash dot dot. Oh, dot dot. There we go. We got that out. I know I sound retarded, but that's okay. We're having fun. Okay, so config FS paths. So I got all these fucking FS paths. I gotta like place them all. So I'd rather have it as a variable. Right. So I'm gonna do this. I'm gonna say auto storage JSON path equals FS path. Uh-oh. Okay. So we're gonna assume that they're running it in the build folder because that's where like you should build and shit. So dot dot slash test slash source slash test. And thank you. Yes, this is the full thing. So what the fuck? What am I doing? With storage JSON path. Okay, so we got one. I wonder if people are low energy. Okay. Okay. Let us see. Where do we do FS path? Wherever we do FS path, that's where we kind of want to fucking be concerned. Alright, so we want to say auto master JSON path and do the same thing. Alright, let's see if this compiles. We will see. Shit. Okay, we got a seg fault. That's fine. At least though, it loads the config. That's what counts. That's what counts, kids. I made my own UUID4 generator. Okay, so let's run this in Valgrind. And I'm pretty sure this is with the virtual volume So, oh, fucking motherfucker. Ah, fuck. Okay. Vibe check. You failed the vibe check. Yeah, so virtual volume, it's probably trying to access the virtual volume pointer, and that's not initialized. Yeah, right here. That shit. The real question is why you have any leaks. You failed the vibe check. The fuck? I failed the mem check, bro. That happens while I'm streaming. I don't know. Ooh, woo, are you trying to access our uninitialized memory? You'll want to borrow that first. Okay. No, what am I doing? Okay, so storage cluster virtual volume. Where the fuck is that initialized? Good point. So this is my hashing shit. Okay, so storage. Singing words of wisdom, ride and see, ride and see. Ride and see, 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 ride and see. Speaking words of wisdom, ride and see, ride and see. Okay. Oh, storage cluster session doesn't even have an initializer really. So virtual volume. So vibe check. This ID is different than the virtual volume ID. Right? What requirements are contained in that? That's a good point. I think we should have a separate setup method for the virtual volume. Maybe. I don't know. Because I feel like I don't know. I don't know. I don't know if Twitch is bad with chat. Well, so let's go in the vault. What the fuck was that? What the fuck? Okay. works on my machine. Alright, so virtual volume. So we have this class. So virtual volume is like a volume that we don't know the size of. It's just kind of like a huge blob that exists on a storage cluster, and like we don't know much about it except that it exists and shit. Well, we kind of know the size, right? So that's not great. So, we got a lot of info here, right? We got this virtual volume shit. But the question is, like, do we want to initialize the virtual volume in the constructor, the storage cluster node? I mean, the storage cluster node kind of needs to know that shit. I mean, that's in the storage cluster node configuration anyway. But what if we're creating a new virtual volume, right? These are good questions. Okay. So, fuck. Let's see. Well, if the one complaint I would have about not having that in the constructor is that without the virtual volume, the storage cluster node is fucking useless. There's no point for the storage cluster node to even be initialized if there is no virtual volume. It's pointless. So, what's the point? What am I using it for? So I had this network called Flatlanders. This is why I created it. And I kind of just got a job and I stopped working on it, but I had some cool ideas. One of them was that Flatlanders was a federated network. Anyone could host a node. You know. And so I thought, hey, what if I made a storage server that could scale, that anyone could host? So, like, you know, content could be truly federated. And I'm like, okay, let me see the options. And so I, like, looked at all the options, and I'm like, oh, all of these are clusterfucks. Like, it's crazy. So I was like, okay, I'll do my own. Fuck it. And that's the story of TinyCDN. But then now I'm like, okay, I can sell the software as a service. So I might start a company in New Year's or something. In which case, if I do start a company, I'll be streaming like 60 hours a week. So that'll be fun. Okay, but then, so the problem is, right, if we have like two distinct behaviors, like we either have either have a storage cluster node that's a new storage cluster node, or we have a storage cluster node that that has a virtual volume already, and we're loading a persistent volume, right? We're loading the virtual volume that already exists. Yes, and we'll hire Mr. Turk here over here. Because, you know, we gotta anyway, so we have this existing variable, so that actually should be part of that, right? So bool existing. what we could do, so instead of like changing the constructor for storage cluster node all the time, I like this idea of like using these params, these param objects, structs, param structs, and basically the marshaller would take that param struct, and you would have like that location of the param struct. So okay, so we have virtual volume params. Virtual volume params. Oh man, I'm like not that effective right now. Okay, vol params. Then so this vol params is like what we'll use to kind of parse into our like storage cluster node virtual volume. So in here, not in here, but in here, see we initialize these. So okay, so we have this to do here. This has to either create a new virtual volume or parse a file pertaining to an existing virtual volume and create that volume. So if we look in like how we set up this JSON, we have the virtual volume like as a parsed. We have this object here, right? And so it'll have this information nation. So we have an ID, and then we have this separate like volume structure. Volumes makes me think of an array. So maybe let's do like volume settings. That's probably good. Yeah, when I think of it like a plural, I usually think of like an array. So anyway, so like this is kind of the setting here. So like for replication, right, we have like a default strategy. Like we replicate 3 times. And then there's like a strategy whitelist, right? So like depending on the virtual volume, we might not like allow certain functionalities. We might not allow certain like replication methods from being run. And yeah, we have this ID here. Let's see. Okay, yeah. Nice text editor, but get a better theme. I don't know. I don't know. I'm a dark theme guy, but I like the aesthetic, man. The aesthetic, man. Okay. So anyway, alright, so this is our like volume settings. So volume settings is like the main gist of it, where we have like this kind of like structure that, you know, we have the size of the settings, things like that. So here is like kind of where we need to do some parsing, because we need to translate like GB into a legitimate size. So if I host a node, how do I prevent from people from hosting weird stuff on my node? Good question. Well, so it depends, right? Because if you're using standard file system, the standard system implementation, nothing's encrypted for now. So that means like you can literally browse all the files that are uploaded, like in a folder. Like you'll see the files, the file names, like everything. Um, and you can just like look at the files if you want. But yeah, the main intention right now is kind of like for companies to use it to create their own private CDN. There's a lot of there's some software on the market. There's not a lot, but a lot of it's really complicated. Like fucking, they're like S3 compatible, but like the problem, like, oh god, it's like awful. S3 evaporate API. Like, look at this shit. This is like, it's like good, you know, in the sense that like there's a lot of like stuff like pausing, resuming, completing, parallel file upload, signatures, like acceleration, whatever the fuck. But it's pretty complicated. Like the protocol, like you have to encrypt certain like portions of the blocks and stuff, and it's just like it's too complicated. Like, you know, I don't understand. Maybe I'm just not an expert or something, but I don't understand like why it has to be so complicated. And in a way, it's kind of because it's designed by committee. It's not designed by like a single person. Um, but yeah, they want to prevent man in the middle attacks. They want to prevent, you know, evil bad guys from doing shit. But I don't know. It's whatever. But it's all proprietary garbage, you know. Like, why? If you're trying to compete with the proprietary garbage, why like make it compatible with the proprietary garbage when you can just like make a better API? That's kind of my perspective on it. Like, why would you like? I don't know. Anyway, so yeah, we have to parse this file. So basically, volume settings we'll make into like a struct as well. Or actually, wait a minute. Whoa, man. So we don't need this really yet. This is kind of, or actually, wait a minute. So, yeah, let's not bother with this. We're gonna just think of limit and size. So where do we get this, right? So let's see. So Jesus Christ. Fuck, I'm almost out of beer. Alright, so right, so Work. It's only 10 p.m., you know? Actually, I really need to start sleeping less. I need to start sleeping like 5 hours a night. Well, basically, when I start my company, I'm going to try to do like 120 hours a week if I can. So I'm going to have to start sleeping less. It'll be hard, but, you know, let's try it. So half of the time, half of the 120 hours will be biz dev, the other half maybe programming, I guess. Probably at first, mostly programming. Okay, so we got location. Oh, that's another one, right? So, this is like not in the config. We kind of just assume that the location is in the... Yeah, exactly. That's how you get ahead. Just work more than other people. I gotta be a complete ruthless bastard. At least according to Dan Penna. I don't know. How does the N with the squiggle... How does the N with the squiggle pronounce? Pena? Pena, right? Pena. No, I don't know. Maybe it's Pena. Okay, so we got, we have to do... why is it virtual volume like also a UUID for, like, there's not that many in memory, so just have it as a fucking UUID. I don't know. Pena. I'm gonna try to ask like an expert in this shit. Like, this won't save much memory if I just have it like, because I'm only gonna have like one virtual volume instance per node, so I don't really have to worry about like saving memory, you know. So why not? Why the fuck not? This is why you're fucking poor. Yeah, it probably makes sense to make them different. Oh well. Let's worry about that later. Virtual volume params. One thing is I have not thought about how the serialization of volume IDs, the volume ID mapping gets created, but that's okay because I have a pretty good conception of what's going to happen there. I want to write and sell my software, just hard to make use of software. I don't know. You have the fucking script. You don't need no fucking case study. Okay? You don't need... The last fucking thing you need is a fucking case study. I love Dan Pena. I'm not like gay for him. But he's got good shit. So location, that'll probably just be in the location of the storage cluster node, right? Or maybe not, you know, because that could be a NAS mount point. What else do we got? We got max size, right? Or size. We just got size. So allocated size is that? We don't have a maximum allowed size is size. Okay. Max T size. Okay. What else do we got? We got oh, wait a minute. So we were saying quite a while ago that instead of specifying a size, there would just be a volume settings of like size, certain size, like the volume, default volume settings, and then like the limit of the number of volumes would determine the size of the virtual volume. And there would be no like, yeah, so that would be much more sensible. So yeah, so we do default volume size, right? Then we would do like, what was the other thing? Volume limit. So what would happen is well, we might want to have that anyway, right? We might want to like have the limit as a variable too, you know? I don't know. Like when you try to add a volume, rather than like checking the size, it'll like kind of it'll kind of like check the limit first. But I guess you don't really want to like persist the limit, because then the limit could change in the config, you know. I guess. So let me see. Anyway, so what else do we got? We got virtual. We got the locate. So we also have the location of the FB vol DB. So that's another thing. So this is like the mapping. So we have like the persistent mapping of the file bucket IDs to their like associated volume IDs. and this is what kind of maintains the so without getting too much into architectural details, essentially the file bucket has a virtual volume assigned to it, which is associated with a certain storage cluster, right? And this storage cluster could be it could still be global, but the issue is, right, like we don't really care where the file bucket's files are being stored necessarily. We don't need to know the exact location where they're being stored, but we need to know they're associated with a particular cluster. So a virtual volume is essentially like it represents itself as a single volume, but it has volumes within it that kind of act as if they're each individual, but actually they're kind of like taking bits and pieces of files and storing them across like different kind of volumes. So that's the idea of it. Yeah, so oh my god. So we're gonna go till midnight. We're going really slow though. Fucking beer. Alright, so FB vol, DB location, volume limit, default volume size, ID, and location. Sibilance. No, I'm not drunk. I have like maybe like a tiny buzz. It's not even a buzz. I had like one small beer. This is my second beer. I might grab another one. Yeah, probably grab another one. I might just embarrass myself, but hey, you know what else are you gonna do? I really want to stream like 60 hours a week. That'd be fun, you know. So we got first volume ID, went max T, default volume size, volume limit. So the size is effectively the default volume size times the volume. Whoa. This is an int. So we just times the default volume size by the volume limit, and that's how we get the size of the virtual volume. Well, the hypothetical size, that's not really a actual size. What else we get? Okay, this is enough. That's enough. Why is this in memory? Why is config file in memory? What the fuck is this? This is why I wish that I fucking documented shit. Okay. So yeah, let's document it. Let's say limit to the number of storage volumes to be created. Sibilance. The default size. That's not true. Default size of the created storage volumes. Or actually, that's not even fucking true because this is just the default volume size, right? Like hypothetically, you can create custom volume size, and then fuck it all up. Whatever. I mean, right now we're not making it so you can do that though. Sibilance. Yeah, I mean, this is pretty straightforward here. So we're gonna take that virtual volumes params as well params. So basically what this is gonna do in storage cluster node, it's gonna basically, it'll have storage cluster params, but depending on whether or not it's existing, we can do different things. So like, for instance, if the virtual volume doesn't, or sorry, if the storage node hasn't existed before, then it's gonna need to instruct the virtual volume to like instantiate its shit, like actually do some allocation, you know, whatever it needs to do. Like create a new database file and shit like that. Make a default volume, commit some, you know, do all those kinds of things. So let's see. Yeah, I know. I'm not actually like, well, so I'm running two computers right now. I'm on my laptop right now, but I got my desktop like with all my chats open. So I have like two hex chat clients on right now. So that's why it's like, I don't really. Okay. Alright, I might get another beer. Fuck it. Yeah. Fuck it. I barely done anything. I mean, this is like a chill episode. This is like episode where like, you know, I'm just chilling. Yeah. Famous last words. If anyone can think of a topic to rant about, give me a suggestion, and I might rant. You know. Anyway, I'll be right back. Just like a minute. I'm gonna like get some beer. So. Alright, no rant ideas. Why do fucking people leave, you know? Like, when I say be right back, it means I'll be right back. People take it as like a social cue, like, okay, now is a good time to leave. I'm like, okay, whatever, man. I'm gonna go watch Fortnite. Okay. Zoom. Okay. My Turkish brother. This is a tiny beer, but it's still really good. It tastes better in Czech, but what can you fucking do? Oh man, it's so relaxing. It's really like, it's got like a bready taste. It's got protein. Believe it or not, it's got protein. Okay, what the fuck are we doing? Alright. So we gotta change the constructor. Basically, the virtual volume needs to be created, right? So like, we kind of put the params here, over here, and then we initialize a marshaler temporarily. So we don't really need this as like a member, to be honest, because like, why? The idea is like, oh wait a minute, a JSON marshaler. Okay, so here's the thing. When we instantiate the storage cluster node, we are probably instantiating it from a marshaler. Because the marshaler, it knows the fields of the JSON file, it knows the fields in the constructor of the storage cluster node, so it serializes the fields from the JSON file into the constructor. So that's straightforward, right? But so this method doesn't even get called by like any normal function. So we can make it pass a struct. This struct has already been deserialized by the marshaler of the storage cluster node. The job of the virtual volume marshaler is not to marshal JSON, but rather to parse the params of the virtual volume into an instance of a virtual volume. Now, arguably, we could just instantiate the virtual volume from the params object, but the reason that we don't want to do that is because the params may change over time. We don't have to want to update the storage cluster node constructor over and over again. So we'd rather just create a generic way of creating a virtual volume from a set of params, defining a struct that we don't fucking care about, like what's in there. As long as the volume marshaler can just instantiate an object, then we're good. So we don't call this JSON marshaler. We probably, we could just create a constructor for virtual volume that takes params, or that converts params. Yeah, it would be easier. So, because marshaler is when we have JSON, right? In this case, we don't really have JSON. We already parsed the JSON. That's kind of, yeah. Or what we could do is we could construct the virtual volume in the marshaler of the storage cluster node and simply take the instance of the virtual volume and move it into the storage cluster node. That would be also an option. The virtual volume can be constructed on its own. Yeah, let's do that. Fuck it. So, in the marshaler for source cluster node, we're going to want to have that field there. Because at some point we're going to use that vol params. But we'll just throw that in the marshaler because we don't need to care about the marshaler. We don't want to care about the params at this point. We just want to have an instance. Because the storage cluster node needs a virtual volume instance. So we're going to put that responsibility to the marshaler. The marshaler will create the virtual volume instance from the JSON file. Then once we have the virtual volume instance, we'll give that to the storage cluster node. Storage cluster node, yeah, that'll work. So that's how it works. Any questions? All right. Waiting for you to give up and use Rust. Did anyone dislike? Okay, no one disliked. Sometimes people dislike the video when I post it in their Discord channel. Because they're assholes. Yeah, Rust. Rust doesn't have periodic templates. Periodic functions. Functions that can take multiple parameters or unlimited parameters. Rust doesn't have exceptions. Rust doesn't have object-oriented programming. I mean, the list goes on and on. The fact of the matter. Alright. This is rant time. He chose the perfect topic. Perfect topic. Let me think for a moment. Alright. Hold on. Where are we at in the code before I completely lose myself? Okay. So we're putting all the responsibility on the marshaler, because the marshaler about to figure out what to do. Okay, so that's we're gonna move that to. Yeah, marshaling is actually PT Dell was the one that made me like that term, just because he used it in some places. Marshaling is essentially when it's serialization, deserialization, and from my point of view, it's like more specifically creation of the object from the deserialized form. And deserialization typically means that, but when I think deserialize, I also think of like you might still need some extra kind of step, right? Whereas I think of like marshaling as like, I mean, it's basically those two things, but it's like a single object that can create many instances of that type. If that makes sense. But I'm gonna rant about Rust in a second here. Let's see. Yeah, I like this idea of just not making it the responsibility of the storage cluster node to instantiate the virtual volume, because then it makes it a lot simpler. Because then it's like, okay, you just assign the virtual volume and tell the storage cluster node and knows what to do. Because really, it's only the hosting service and uploading service. It's really only those things that really touch it, right? Anyway, so Rust, so exceptions. Let's start with exceptions. Exceptions simplify error handling code by essentially letting you think about the control flow of the program without thinking about certain circumstances that might make your program unable to finish its task. So, for instance, file I/O is a very good example. File I/O can fail at any point. When you're writing a file, creating a new file, anything, you can run out of storage. There's all sorts of situations that can happen. So my kind of central agreement, with exceptions, why I think exceptions are a good idea is for those kinds of cases where you have so many potential things that could go wrong, rather than have to handle each and every single case at each and every point, it makes sense to have some sort of generic way of handling an error in a different part of the program, i.e., let's say you're in the call stack 8 levels deep or something in some routine that's doing something complex, and you have a creation of a file that fails. You would have a top level object that instantiated some factory that instantiated some like component, and that exception gets handled all the way at the top, because those details don't matter at that level. They don't matter at like the level of like every single method needs to care about the details of the file system. So the problem I have with, error handling at every point is that it should call itself, it should be handled by kind of like the provisioner of the task rather than like the deepest method, where that could go wrong. I don't know what this is. Try. Yeah, this question mark thing is like basically you're having like a maybe. And maybes are great. Like, I love optionals. Optionals are great. Like having a notion of this may or may not have a value, and this value that may or may not exist is either just that value or a none, and that's a great idea. But there's certain places that a lot of places that having an optional at every point in your code, it makes it a pain in the ass, because your error handling ends up being in 10 different locations. You have places where you can never really guarantee that a function will always return a value, because if there's so many cases that a function doesn't complete, then you have to do all those manually. You have to basically have some sort of way of some fine-grained component communicating with a top-level parent component that has the error logger that it needs to unwrap to that level, where the error logger is, and then it can log the error, etc. The problem with that is like it doesn't make sense everywhere that a function can be used outside of the scope of a very specific situation. So like when the thing is, and this is why object-oriented programming is great. Okay. For instance, I have this architecture, and none of the methods in, say, storage cluster make sense in the context of master. Okay, because if they were just functions, anyone can call them. There's no association with an object, then yeah, it should return an optional. It shouldn't expect that someone handles an exception, whatever. The problem is that if you have functions if all functions are public, if all functions can be called, if they're designed to be called by anybody, the problem is that each function becomes absurdly complicated. And rather than like each function essentially being a piece of like an overall kind of control flow, you have this like problem, and you see this in a lot of kind of functional languages, and you see this in like Rust code, etc., where one function has a huge amount of code, and like generally speaking, a huge amount of code, huge amount of error handling code, huge amount of like boilerplate, so that it can be like doing everything, just so that it can avoid like mutable state, just so that it can avoid basically being a noun, right? So like the point of an architecture where you have objects like a file storage node, a master node, a storage cluster node, storage cluster node, master node, etc., is that you have a metaphor, you have a common metaphor, you have a grasp on the control flow of your program as it pertains to like this node does this node does this, and this kind of like noun verb association makes it very easy to describe what your program is doing. And like this is the problem, right? This is the problem. The people that believe object-oriented programming caught on for no reason, or because it there's people that hate object-oriented programming often say that object-oriented programming has no point, etc. It's like this, right? Object-oriented programming obviously became popular for a reason. And not even just a single reason. It had to be many reasons. It's not like Java, C++, all of these object-oriented programming languages were just like, we're just gonna convince people of things that are false. And the herd's gonna follow because people think it's true, whatever. Generally speaking, like that shit happens where people just follow the wrong trend. But what will happen is that the market is usually rational. The market will be like, okay, the people that use object-oriented programming languages are going to fail because, object-oriented programming is unsustainable, whatever, it has all these problems, it's not going to add any value, whatever. But in fact, you find the exact opposite when, and this is a really good kind of video on this. Next Step versus Sun OS. So here's a really good video. I'm not going to play it because I don't want to get copyrighted. But basically you have this like thing and where they had two programmers. They had a Sun programmer using C. And they had a, C's not a functional language, so, whatever, but just for the sake of example, you had a program using C, and you had a program using Objective-C in the Next Step system. And they basically compared how long does it take to create the same program on two different completely different systems. And what you find is that the object-oriented programmer gets a lot more done. It's less code. And the reason why is because things are more, kind of relatable to your average human being. The notion of a printer, having a printer object, you instantiate the printer object and you can do actions on the object, like send a job, etc. That kind of follows naturally. And I'm not of the opinion that methods should be attached to objects. I think methods should be basically acting on the type of, the object it acts on, with that parameter being the first, I like how NIM does object orientation in Common Lisp. Anyway, the point is you have a type, and a type is associated with side effects that are not like deterministic, but necessarily so, because the kind of association of the printer with, sending a job or whatever, all that stuff, it's a physical process. It has state. The printer is either printing or it's not printing, and having a Boolean for that state, it just makes perfect sense. Like the idea everything needs to be immutable, like how the fuck is that simpler? How the fuck is it simpler to not have a bool and instead have some fucking monad that's like acting on like some immutable state of a different printer object, basically, or different type of printer that's not printing? It's just ridiculous. Like, in many situations, it makes sense to have a mutable state to have an object, because the interface isn't necessarily encapsulating the entirety of the control flow of the program. And I think objects do so in a way that makes sense to the human mind, and it makes sense in the sense of, and it has problems. Obviously, you can abuse it. Obviously, you can create these God objects, you can do all these terrible things. And in a way, object-oriented programming made it much easier for these kinds of poor design decisions to happen. That being the case, when you have a distributed architecture, like I have, there's no fucking easy way to describe such a complex system without having nouns to describe what the fuck it's doing, without those nouns being, stateless or fucking, like, without those nouns just being types, those nouns just being types. No, they need to have state. It's like, you need to have a fucking, I could design this, I can design this in Rust, or I could design this in Haskell, I can design it in a system with no object-oriented programming, whatever. But if I tried to explain how the system works, it'd be very difficult without nouns, without being able to say, okay, this object does this. So in this like description, I'd say like file storage. The file storage node has these responsibilities. It stores this and this and this, etc. It'd be very difficult for me to say what it does without saying the node does this, the node does this, the node does this. Without being able to say that, it would be like I'd have to explain the entire process, all these functions get called, yada yada yada. This side effect goes, or there's no side effects. This node has these sets of functions, and they go in this flow, and these monads, and these, it's just, it's like, it sounds great from an abstract point of view, it sounds great from an academic point of view, but when it comes to, like, explaining it to, like, not even just an average person, but, like, another programmer, it's fucking difficult. Like, it's like, how the fuck am I gonna have my code base be reusable if, like, every part of it is a function, is like a functional piece of code. And you find that, like, and I've studied some functional programming, like, I know what it's about. When you go into these functional code bases, there's like a huge, like, there's a problem, right? There's like an inflection point where, like, you can kind of, you have like a curve, right, where it's like your reality is like, okay, I don't get it at all, and then you're like, I kind of get it, and then you hit this wall. You hit this wall where, like, you have to, like, be this fucking high in, like, homotopy type theory and, like, all this other shit, and, like, until you reach that point where, like, you can literally understand all of type theory and all of this shit, until you're, like, PhD level in all of this homotopy type theory stuff, you won't be able to understand the code base. And that's a problem. Like, you should not hit that wall. It should be like, you're here, you might struggle a bit, you might flatline, but then eventually you can kind of get here without having a PhD. What are you saying? What that's called a trait? I know what traits are. But again, I don't like C++'s type system, like, super much. Like, I think methods should be separate from objects. But objects are very good in the industry shows this. I mean, people are going, there's a reason it was adopted. It's not just because it was a meme. Like, it's anyway. Yeah, defining behavior for a noun of a particular domain. Okay, yes. But a trait is different because you're limited in the fact, like, traits are cool, but you're limited in the fact that you're not actually really implementing functionality in the sense of like an instance. You can't ever deal with a real instance. You're dealing with like a trait has to be compatible with any object that implements that trait, in the sense of like a trait has a more limited scope. Like you have less, you can make less assumptions, right? You have to make it as generic as possible. Without washing their poopy butts. OP's a poopy butt. I don't know, man. I've written a lot of software. I haven't written a lot of, functional software, but what I know is when you try to communicate software, well, the number one thing that distinguishes a senior programmer from a junior programmer or mid-level programmer is not programming ability. That's a mistake people misunderstand. It's communication. If I can't communicate what my code base is doing, then I am not a senior level programmer. If I can't communicate to a junior level novice what my program is doing, then there's a problem. At least at some like subtle, new, vague level. And yeah, that's the problem with functional programs. How is a novice going to understand most functional code bases? At least like highly advanced functional code bases. It's very, very difficult for me to think that that's possible. That you can have a complex system in that sort of design and be able to explain it to somebody that is a novice in that language, like what's going on, or novice, in general. Please try Rust for a few weeks. I've tried Rust. I didn't get that far because I ended up using C++. But I kind of I've seen a lot of Rust code actually, and I've studied it a little bit, and I've had people that are really obsessed with it that can't stop telling me about it, and I don't know. I don't like. I don't like how if I write code in Rust right now, there's a good possibility that it won't work in a few years with a newer version. Whereas like my C++ code, it's gonna work until fucking 2050. You know what I mean? Like, it's gonna work for a very long fucking time. And you'd be like, oh well, the cargo package, you can just have the Rust version in the cargo package, but it's like, am I going to be able to hire a Rust programmer that knows that specific version of Rust? That like can deal with like the specific versions of the library, and like the library is dependent on that Rust version, might have some security flaw that gets patched in like a way later version, but I can't use that version because that version uses a Rust version that's like 3 years older. It's like, well, so that's the other pragmatic side of it. Like I knew, there's tons of flaws. Like I understand, like a newbie getting a C++, you're like, holy shit, this language is terrible. First of all, it's improved a lot since C++ 11. Second of all, I don't really have too much of that problem because I learned it when I was like 10 years old. Sorry. Well, I learned it when I was 10 years old. Well, learned it is like a bad thing to say, right? Because people are like, oh, you can't learn it, whatever. It's a huge language. But I learned some. I used it like for a while. I had like a huge thick book, Visual C++ book. I'll never forget. It was huge. It was like 800 pages. It was from my dad. He had it in his office. He had a lot of Microsoft books, and I just remember being in elementary school, leafing through this fucking huge book on Visual C++, and it was like so funny. And yeah, I would do that. I wrote some text-based RPGs and stuff, and I ended up hating the language, or I convinced myself I hated it because I started using Python, and then I got exposed to this programming community that's, using C#, Java, Ruby, all that shit. No one fucking liked C++, and I just didn't know anything about it until like 3 years ago. And then I'm like, oh, this isn't that bad. It's ugly, but it's fucking fast, and I know, basic shit because I studied it so long ago. So I gave it a whirl, and I'm like, hey, this is like, it's alright. It's like, fucking works. Just works. TM. And plus, it's gotten a lot more functional over the years. Like, it's gotten a lot more like Haskell. Like, optionals, fucking... Like, look at this shit. Look at this fucking... Also, I need to get back to programming because I'm just ranting right now. But look at this shit. Like, this is like... You would look... This isn't C++. You look at this and you're like, this isn't fucking C++. What the fuck is this? And you're like, oh, this is like static dispatch. This is like sum types. And you're like, oh, okay. Interesting. So, I'm forced to in the position of defending it because people are like, oh, why aren't you using Rust? And I have to defend my decision because a lot of people think I don't want to be the guy that gives tacit approval, right? First of all. Second of all, like, oh, I know Rust is whatever. I don't want to be that dumbo that's like, well, C++ is just what I know. It's just like, I don't want to learn Rust. And then I appear as like this ignoramus guy that like doesn't know shit. He's just like a boomer. But it's not just because I'm used to C++. It's not just because I'm used to C++. It's because it's because I have specific reasons. I have more than one reason. So, fuck you. Just kidding. I love you. Anyway. Plus, like, fucking unique pointers, shared pointers, fucking great. It's like, it's like pretty much gives you like 90% of like what you get with the barring system shit. And it's like, it compiles faster too, like fucking Rust can do like 4,000 lines a fucking minute. or second. No, 4,000 lines a minute. Like, holy shit. Imagine writing a kernel in a language that can only compile 4,000 lines a minute. Is it second? I don't know. But anyway, think about that shit. Like, people are like, oh, let's rewrite the Linux kernel on Rust. And, like, I'm pretty sure, I don't know how long that Rust kernel, there's a Rust kernel, like an entire kernel written in Rust, and, like, who the fuck knows? But yeah, I'm curious if you take any Rust 1.0, Rust 1.0, right out of the gate. If you took any Rust 1.0 code base and you just incremented the version on every single library, and if you updated to the latest library conventions, if like you would have to update your Rust version, you probably would. You'd probably break everything. It'd probably take just as long to upgrade from that version to the newest version as it did to develop the code. That's my theory. Anyway, what the fuck am I doing? I wanted a rant. That's what I got. Oh, I actually did a lot. No, I didn't. I didn't do that much. Holy shit, I've done like nothing. Alright, let's get serious. Okay. Alright, so now the storage cluster node constructor takes the virtual volume. Alright, so great. So what we'll do is now, so where do we instantiate the storage cluster node? Storage cluster session. Okay, when we create this storage cluster node session, we need to create the virtual volume. So in storage cluster node session, storage cluster session, when we spawn node, that's when we instantiate the storage cluster node JSON marshaler. See, this is where we get this information. So maybe let's go in the marshaler and let's make this actually do some shit. So we have deserialize. Maybe instead of taking this, we can take a stream, because that would be better. If like deserialize took a config, why is this taking this? Oh, config is parsed. So parsed is a parsed config. So deserialize, we don't want to take a config. This is like going from string to unique pointer. Like, that's not what we want. We want this to be the storage cluster param object, and then and actually we want to move the storage cluster params into the marshaler because that's not referenced anywhere else. Same thing with this. So let's put that there. Let's put that in the marshaler code. Let's put it in the marshaler code. So this is volume params. Oh, actually, hey, we already started on that. Oh, so we have, yeah, this is just a copy of some other shit. Oh, this is CSV Marshaler. Okay, yeah, so it's different. So virtual volume params, we're going to move here. We're going to use inheritance. Ha! Ha! Inheritance. Ha ha. Liberal. So you went max T size. See, we have actually, fuck that shit. Let's not inherit that shit. Let's not do that. We don't need that. Oh, wait a minute. No. We can do that. Okay, so what we'll do. Yeah, it is apples to oranges. You're comparing a stable language with a not stable language. Why would I want to use an unstable language for an enterprise or scalable enterprise storage solution? It's like kind of language might offer me significant market advantage, but if I'm working this in my spare time and I don't have time to keep up with the language changes, does it really make sense for me to learn a new language and stay like autistically obsessed with that language? Or, I mean, you'll find that a lot of people like Rust, and people, for some particular reason, they have this need to constantly stay like fucking around with it, and then like when it comes to like building products or like building fucking useful software, not just libraries but like useful software, a lot of people will stop at the fucking around and they won't get to the useful software stage. So I don't do that. I write. Not to say that you can't write useful software in Rust, but like if you're fucking around all the time, you're learning the language all the fucking time, and you're fucking around, there's a very small chance you're gonna be developing a product or something that's actually fucking useful for the user, because you're spending so much time fucking around. And the truth is, when you're trying to build useful software, you don't have time for bullshit. Okay, you don't have time for bullshit. So that's why you don't fucking fuck around. So that's my perspective. Okay. Okay, so you probably want this shit before that shit. Also, here's another point. Let's say I want to hire some guy to work on this shit, which I probably will. How many Rust programmers are going to do this shit for money? Most Rust programmers are going to work on their own shit or open source shit for free. And if you ask them to work on something for $20 an hour, they're going to say, it's not worth it. It's not worth it. It's not worth it. You know, some 40 an hour, you're going to say, it's not worth it. You're going to have to pay them a fuck ton of money to not fuck around. You're going to have to pay them a fuck ton of money to build useful software. Otherwise, they're just going to fuck around on their own shit. Right? And there's not that many of them. There's just not that many of them. Most of them haven't even built useful software in Rust. They've just kind of fucked around. So the number of Rust programmers that have actually built useful software using Rust is very small. Most people are just enthusiasts. They like the language. I appreciate that. I think Rust is great in many ways. But there's a certain bullshit threshold. It's like, how many people are fucking around and how many people are building useful shit? If the number of people fucking around is much larger than the number of people building useful shit, then it's a waste of time to consider hiring people to work on shit written in that language. At least from like the perspective of like ease of hiring, right? That's kind of brutal, but you know, whereas if I can hire like, I could find like 10, 15 people, you know, to one Rust programmer to work on the same shit, and they're gonna work on it for much less. They're gonna probably have years of experience doing the same goddamn shit. They're gonna know exactly what the fuck to do, and they're gonna fucking execute. You know, if I hire a Rust programmer, what the fuck am I expecting? You know, this is unproven shit. You know, like, it's unproven. And yeah, there's large software in Rust, but like, let's take Servo. Servo's like been in development for like a few years, more than a few years, since Rust's inception, basically. Is it fucking done? Does it work? You know, I understand Servo is very complex, but does it fucking work? Is there like, you know what I mean? So, anyway, that's kind of my perspective. Yet again. Anyway, so virtual volume. And volume limit. Okay. This is not a very productive episode. I blame the beer though, because usually they are productive. How long have we been streaming? 2 hours? Yeah, we haven't done shit. Okay, virtual volume. That's wrong. Volume params. Okay. Okay, so virtual volume params. Great. So that's in the marshaler. So here we want to import the volume marshaler. And we want to instantiate the marshaler. So we take storage, so we have storage cluster load config. This is where the magic happens. This is where we load the config file, create the JSON marshaler, do all that shit, okay? So here we're responsible for taking a standard string input, or in this case we'll have a, we do convert it to string. The JSON library probably can do that for us, but anyway, so we take a string and we're converting it to a storage cluster params. And a storage cluster params is what? Do we have that as well? So I want to move storage cluster params to the marshaler. And yeah, the reason why is because this is basically only relevant to the marshaler. It's not really relevant to any other class. The marshaler is responsible for taking a params object and converting it into a instance, and basically we'll have a function that does that, and that's going to be called I guess get instance. So let's say get instance, and it should take one of these params objects and convert it. So let's say config well, yeah, then we will return a, do we want to return a unique pointer, or just, yeah, we want to return storage cluster node instance. Storage cluster node itself can't be copied because it has unique pointers. So we want to return like a unique pointer. Well, but we have an instance. This is the issue. Singleton in an instance creates the instance. So like, I know you. You're Mellow Mike. So singleton in an instance gets called, and like, that's the problem. We don't really want to do that here. We don't really want to do that right here because we're trying to instantiate the instance in the fucking marshaler. So instead, what we're gonna do is we're gonna say get singleton, and it's gonna fucking return a singleton. So there we go. So get singleton. And yeah, that'll solve it. So so instead of having to do that, we'll basically just assign the singleton to the marshaler. get instance function. Sorry, get singleton. So the marshaller will convert the config into a singleton object. And there we go. So let's move this into this function. So I'm going to jump into so we don't have that there. So let's do this in line for just a brief moment. So we're going to say we're knitting an instance singleton. Okay, so we have in this case, so we have a singleton. So we're going to allocate this. We're going to return the singleton. Okay, so we want to say storage cluster node singleton. We want to instantiate the singleton, and we want to do singleton done instance, and we have all these parameters, and so this is going to take it from the storage cluster params, and that's what returns from deserialized, right? So we're going to say, like, we're just going to say something like this. We're going to say marshaller deserialize, and that's what it's going to take. It's going to take one of those configs. It's going to take the config that's parsed here. Or sorry, it's just going to take that config, not the deserialized config. The config's already been deserialized at the point of instantiation here. So essentially, what it's going to do is it's going to return, instead of storage cluster params here with nothing, it's going to return marshaller deserialized. It's going to return the deserialized string, which is config. So it's going to turn marshaller.deserialize config. And yes, that's how it works. So I'll take that. We don't need the marshaller. We do need the marshaller. So yeah, we instantiate the marshaller again. And of course there's some exception that might get thrown. Some kind of parsing error. So we get singleton. Yeah, assign the singleton. Do all this shit, and then there we go. So fix wait. Yay! This is my third beer. So wow. 2 of these Pilsner Kells, and then I had 1 big boy. So effectively, so how many pints is this fluid ounce? Well, effectively like 2 pints, essentially. That's not much. So I'm tired. I'm a whiny baby. Okay, so storage cluster params. And, you know, this has virtual volume params here. So that has to be from that. So we're going to include volume marshaler. And essentially what's in here that we need is this virtual volume param. And basically this is the structure of the parameters. And then so what we do here in singleton in an instance is we have to provide the virtual volume instance. So and we're gonna have to change this in the instance here because we're gonna need that standard unique pointer now. This shit annoys me. Virtual volume. We'll take that shit. Do we include volume here? Yes, we do. So we get that shit. What is this theme? It's legendary. So I think this is like one of, I don't really know really what the Emacs theme is, but this mate theme is Chicago 95. I like the aesthetic. Gives some character. I like it. I'm typically a dark theme guy. Like I like dark themes for my editor, but I've gotten used to like this Windows 95 shit thing, so I really like it. So yes, so let's see. Okay, so we want that type here, so let's go into storage cluster C++. It's in storage cluster singleton an instance, okay. And we just pass virtual volume there as well. And yeah, so that's the way the news goes. Marshaler, config file location execution, Marshaler deserialized config, singleton get singleton. Okay, so yeah, the config. Okay, so yeah, we basically want to, instead of putting this crap here, we want to get the params out of the cluster params. So basically it goes something like this. We just instead of putting this bullshit, we have to well, so we'll move this to here as an example to make actually work. Make this actually work. Basically what we're going to do is we're going to return So we're going to do storage cluster params. And we're just going to do params d equals that. Then here we do params d. Sorry. Let's call this params. Params id. I want to say like params.name. You know, shit like that. Params location equals path. Shit like that. Virtual volume params. And that's the kind of difficult part that we gotta do. We have all these things here, so and then we're gonna say like virtual volume params params. I don't like doing the like shortened variable name type shit. I'm just not like that. So location, we basically want to take params location, and then like let's put just v params. This is okay. V params location equals params location slash volumes slash, let's say, test. That data. This is so virtual volume location is kind of weird because like whatever. Volume, yeah, let's just do volume. Location of the DB file, we want to say like v params v fb vol db location. We want to say like v params location slash you know, we're gonna say GPG, or what do we want to say? We want to say volume DB, like that. Volumes.db, some shit like that, and that'll be the mapping. Message. default volume size. We're just gonna say like. So I made this cool little syntax. So if we go like, if we include utility, and this cool like, it's kind of, this editor fucks up the syntax, but I can do something like this. Utility HPP. I like saying CPP instead of C++ because it makes me feel silly. So include the utility header, and I can do this cool little thing where I say v params default volume size, and then I can say like, you know, MGB. Pretty cool. So that'll be, that's like 1 gigabyte, but as a uint max t. Oh, that returns standard size t. We actually want to return like uint max t. Anyway, we have that there, and then volume limit, let's just say 4. There we go, so we got vparams, and then we want to do params dot virtual volume. Oh, params. We want to assign that to vparams, and we want to return params. So so this will eventually actually parse the file, JSON file. For now though, we just kind of fuck around, but we are getting the general structure good. So yeah, we parse into virtual volume params, assign the params, return the params. So now we can just do this shit. So we can say params. So we want this marshaler to instantiate a virtual volume marshaler, and then we call the virtual volume marshaler deserialize, and then we can once that gets deserialized from the string, or sorry, deserialized from like the object or something, then that's good. So yeah, so it'll look like this. So say virtual volume JSON marshaler. We'll say virtual volume marshaler, and we'll just do this. We'll say virtual volume marshaler get instance, and we'll get an instance from the config. So we will take a config here, auto config virtual volume config and virtual volume marshaling dot deserialize, and then that subfield here. For now, I'll just put the empty string. Actually, this is gonna take a JSON object and deserialize from a JSON object. So it's a JSON object. And so we're gonna return that, and that'll get us the config. Config and so we're gonna say volume virtual volume marshaller, get instance, give it the volume config. It's gonna return us a instance. So yeah, and params ID, params what else? Singleton and an instance. I'm probably gonna stop like really soon because I'm not like buzzed. I'm just like tired now. Yeah. Oh, location. Params location. And then yeah, we get instance from the volume config, and then we init instance from singleton and return the singleton. Okay, yeah, I'm gonna stop. I'm getting tired. Thanks you guys for watching. I hope you enjoyed this kind of slower episode. Just kind of relaxing at the end of the day. So, you know, take it for what you will. But anyway, most of these episodes are a bit faster paced. I've kind of just been ranting a bit, drinking some beer, you know, doing that sort of stuff. So thanks for watching. Hope you guys enjoyed the episode, and yeah, I'll be back maybe tomorrow. Maybe I'll stream tomorrow. Fuck it, you know. I'm really enjoying doing this like consistent streaming like I used to. So yeah, we'll be back tomorrow or Friday, Saturday, probably every day. So thanks for watching. Cheers. Good night.